Finally, we reached some of the fun stuff. Today we're going to discuss the product and quotient rules. This is what the first incorrect product rule, that's what a lot of people think that you should do. You should just take the derivative of each function and then multiply it. Well, that's not the case. The correct product rule, instead, is if you have two functions, f and g, being multiplied, you take the derivative of the first, multiply it by the original second. Then you take the first function and multiply it by the derivative of the second. It looks complicated, or it sounds complicated, but it's not. You just have to make sure you have the derivative of one and the original, and then switch it around. Later we'll expand this into a triple product. That'll be even more exciting. So for the first one, we're going to use the product rule. We're going to solve this using the product rule. Then we'll verify it with the power rule, which is what we would have done before today. Okay, so the derivative, we see two distinct functions. We have x, and we have the quantity 5x minus 3x squared. So we're going to take the derivative of the first, which is 1, and then we just write down the second function. Okay, plus write down the original function, and now the derivative of the second one. Okay, so now if we simplify this, we get 5x minus 3x squared plus 5x minus 6x squared. So it looks like we'll get 10x minus 9x squared. Okay, we could have done this another way. We could have first expanded this and then taken the derivative. Okay, it seems a little shorter in this case to use this method, but we have our options available. It may not always be as easy. All right, so now we have this one. This one's a good one for you to write in your whisk. It's not too difficult and won't take too much to type. So you try that one. I'll show you this one. In this case, we got a product here. We have 2x times cosine x, and the other one is just its own function. So if we take the derivative of that, the derivative of 2x is just x, then we just write cosine plus this times the derivative of cosine, which is negative sine of x. And then, oops, right all over the screen. And then what's the derivative of negative 2 sine x? That would be negative 2 cosine x. Okay, big mistake here. This x, the derivative of 2x is not x. The derivative of 2x is 2. Okay. So now I have a plus 2 cosine x, a minus 2 cosine x. Those parts disappear. And the derivative is negative 2x sine x. Good thing I caught that. Now the quotient rule. This one is fun and so easy to use if you remember a little song. This is the incorrect version. Don't do that. This is the correct version. Now you can remember it using that algebraic notation, or you can remember it by listening to me or yourself in your head singing a terrible song. Okay, think about our good old seven dwarfs here. They're always singing, you know, when they hop down the cave and they got to use their pickaxes to break off the rocks. They're saying, you know, hi ho, it's off to work we go, you know. And then hopefully some of you know this, Mr. Wilson, who you never really see his face, he's greeting Tim, the toolman Taylor. He's like, "Heidi ho, neighbor." Well, think about him if he was maybe dyslexic. He might say, "Hody hi." Okay, or Santa Claus might be in a hurry. So we have this quotient rule. You can think about it, if you think about the top, the numerator as the high function, and the denominator as the bottom function, the ho function, or if you don't like that, you can say low, but we're going to say ho-de-hi minus hi-de-ho, all over ho-ho. You can make the bottom sound better. I don't know what to do with it. I don't sing. Okay, so you're lucky you got that. So that's what I want you to think. Every single time you do a quotient function, think ho dee high minus high dee ho. All right, got it? Over ho ho. So here we go. We're going to do it. I'm going to make my pen a little smaller. dy dx equals. Okay, so we think ho dee high. So we have ho dee high minus high d ho. Okay, the d part represents the derivative. All over ho ho. All right, let's clean that up a little bit. Technically, you could just leave it there, but I like to clean it up. And a little bit more. Oh, look at that beautiful function. Okay, again, let's do this one in a different color. Sine over cosine. Hey, wait, that's tangent, isn't it? Interesting. All right, f prime of x. So we have ho d high. I'm going to run out of space, but I'll just write it here. Minus high d ho over ho ho. Oh, look at this. We'll have cosine squared x plus sine squared x. Good thing we have those Pythagorean identities. So we have 1 over cosine squared x. And then, wait, that's something. What's the reciprocal of cosine? Secant squared. So, fun fact of the day, the derivative of tangent of x is secant squared of x. Interesting, right? Wow. All right. I guess we could do a couple more, right? Why not? Find the equation of the tangent line of the graph. Stuff that we've already been doing. Now we just have a fraction. So for a tangent line, we need a point and a slope. So what is f of -1? That would be 3 plus 1 will give us 4 over 4, which is 1. Yes, okay. We need the derivative function. Say it in your head. Ho, d high. What is the derivative of this? Well, that's x to the -1. So we're going to multiply here. We get +1, x to the -2. Ho d high minus high d ho all over ho ho. Okay. We can rewrite it if we want. I'm just going to throw this 1 over x squared, so it'll be easier. I'll plug it in right here. Why not? F prime of -1. So that would give us 4 times 1 minus, that would be 4 times 1. Well, that's exciting. And on the bottom, we'd get 16. That's 0. So we have our point, we have our slope. Let's write the equation line. And again, I'm going to use Taylor form. Y equals, really exciting here, 1 plus 0 times x plus 1, or just y equals 1. Guess that means there's a horizontal tangent line right there. All right, last example for the day. Evaluate each of the following. Looks like we have a combination here of the product and the quotient rule. Another time for a skinny pen. All right, here we go. We have ho d high. If we take the derivative of the top, we would end up using the product rule. 1 times sine of x. Oh, don't do it. 1 times, come on, pen. Sine of x plus x times cosine of x. Ho d high minus high d ho, that would be 1, all over ho ho. All right, you can leave it. or you can expand it. For the sake of time, I'm going to leave it. If you want to expand it, I'll check if you want me to see if you're right. All right, let's change the color here. Now, again, we're going to have a product rule and a quotient rule. So for this one, we're doing a product. So I'm going to take the derivative of the first one. So we have ho d high minus high d ho all over ho ho squared times sine of x. That was the derivative of the first times the second function. Plus, I'm just running out of space here. Plus, we have the first function times the derivative of the second function. And there you go. And again, you can clean this up. And you'll actually see, if you clean them up, that these two things are equal. Because it didn't matter if you group it as x over x plus 1 times sine, or if you group it as x times sine of x over x plus 1. Have a great day.